Welcome back, friends. I'm so happy to see you here, ready to learn more about what to do with those unlike denominators. Maybe you checked out that addition lesson and how we can visualize those common denominators. Maybe you even remember this piece of paper that we folded in thirds and in fourths and ended up with all these 12 cool sections. Well, we've got a graphic approach for subtraction too. But you're going to need a piece of graph paper, a straight edge, and some groovy colored pencils. Let's think about a problem like 1/3 minus 1/4. Where do we even begin? We could get out the scissors and start chopping this thing up, or shall we try this method here and see if maybe we can also visualize the process of coming across the common denominator? Let's get our paper ready. And let's write out that problem. 1/3 minus 1/4. One-third minus 1/4. Just like with addition, we're going to create a gridded rectangle defined by those two denominators. You may remember this one from our first addition example, 1/3 plus 1/4. Yes, we're going to work with those two fractions in reverse. Our rectangle is 3 across, 4 down, and go ahead and fill that in with its grid. As you can see, we have a rectangle, 3 columns, 4 rows. And how many pieces total? The same as last time, 12. And that is something we can write down right now. We can also pick 2 awesome colors. Oh, wait a second. Actually, just 1. Think about it. With addition, we may have 2 things that we're putting together, but with subtraction, we just have something and we're taking something away from it. We actually don't have that other piece yet. We just need 1 color. We're just going to color the first part of our subtraction problem. Now take a look at your rectangle. We're going to choose one of the 3 columns to color in. Everything is pretty much as it was with addition so far. Until now. Usually we don't do anything with the parts we don't have, but this time we're going to make sure we do not have them. Take your gray pencil and go ahead and shade them in gray. We want to make sure that when we're taking things away, we don't take anything away from these because there's nothing there to take. We're going to symbolize what we take away from that 1/3 with check marks. Now listen, there's 12 pieces here. We still have to take away the right number of pieces for that 4th. What I mean is, normally we'd take away 1 whole row there. All 3 of those pieces and that 1 of 4 rows would go away. But there's nothing there. We still have to take those pieces away. How many check marks would we have if we filled these boxes in with check marks? 3. Well, we can do 1 of them, but when we get to the grays, we cannot take the grays. So what are we going to do? We're going to take from what we do have. Take a look. We just checked off 3 of those boxes. And now we just count what's left. The 1 active box, the 1 12. 1/3 minus 1/4 is 1/12. How cool is that? Let's try something a little bit more strange and wondrous, like 5/6 minus 2/7. 5/6 minus 2/7, and that rectangle will be defined by 6 and 7. Ah, goodness, a string mark. Well, hold on a second. There's nothing like a little bit of magic to brighten your day. Okay, take a look at your rectangle. How many pieces total? 42. We know part of our answer already. The denominator is going to be 42. Now again, how many pieces do we have? 5/6. So we're going to choose a color, and we're going to shade in 5 of these 6 columns. That last one we're going to shade in gray because we don't have it. All right, it's time to apply the check marks. 2 of these 7 rows must be checked, but hey, we're going to have a problem taking these 2 away, so we're going to have to take 2 more away from that. All right, here goes the first of 7. Here's the second of 7, and here's me taking those 2 that I'm owed. I'm much happier now. How many spots are left over from where we checked off? "23." How fantastic. Let's write that down. Can we reduce that answer at all? Not this time. Let's try a really absurd one with a mixed number now. How about something like 2 2/3 minus 1/5? This is going to be really crazy, but what we need to do is sort of figure out what 2 2/3 is, and, well, in the meantime, we can get a rectangle set up. 3 by 5. All right, we made our rectangle and we broke it up, and how many pieces do you see? 15. So maybe we know a bit about our answer, but first we need to figure out how much we're going to shade in. And, well, why don't we pick a color to shade in? That's a big number to be coloring in. It's a mixed fraction. 2 wholes and then 2/3. So how do we show that? Well, do you remember with addition, when we had 7/6, we colored in that extra row? Yeah, it was a column, and yes, we're going to have to do that again on this one. But what is 2 2/3? When it's not as a mixed fraction, when it's an improper fraction, what does it look like? 8/3. Let's write this down just so we have a little bit of a store of our work. We'll rewrite our problem down as 8/3 minus 1/5. Now we need to shade in 8/3. So that means these 3 columns plus, yep, 1, 2, 3, 4, 5 more. Have fun. Whew, look at that. Look at all those extra thirds that we have. 8 of them. All right, so now we need to take away 1/5. We need to check off one of those 5 rows and just of the original whole. So There we go. Now we also know our common denominator. Count up those squares again. 15. And what is left of our 15ths? Yes, you have to count all of these too. 37. 37 15ths here. And we can change that back to a mixed fraction, right? How many wholes of 15 can we get out of there? 2. And how many are left over? 7. Our final answer. Whew. 2 and 7 15ths. And I don't think there's a way to reduce that. Well, friends, I'm glad to have shown you a way to visualize this common denominator thing. Go have fun with this, and if you're ready to learn a little bit more about the arithmetic way of doing it, check that out as well. See you again soon.